Hello students, myself Dr. Kulvinder Singh, now taking the second part of the lecture for length measurement. And in this lecture, we are going to understand that how screw gauge can be used for measurement of the small length. In my previous lecture, we have seen that vernier caliper can also be used for measurement of the small length, but it has a limitation. The least count of this instrument is 1/10 of a millimeter. Least count means the minimum distance it can measure. But if we have the length less than this, then we have another instrument and we call this as the screw gauge. Now this screw gauge has many parts. So let's first of all understand that what are the parts of this instrument, that is the screw gauge. Students, as a first step, let's find out the least count of the instrument. You can notice that there are two scales in it. One is marked on its sleeve and we call it as the main scale. This is the main scale. And the one which we can rotate, and the end of it, this is called the circular scale. It is having a shape like this. Try to notice one thing, that on the main scale, when it is 0 to 5, it means this gap is 5 millimeter or half centimeter. And there are 10 marks in it. Notice 5 are marked on the upper side and 5 of them are in the lower side. So there are 10 marks, and if you find out the least count of the main scale, we can say the least count of main scale is half the millimeter, or we can say 0.5 millimeter. The next thing which you have to do is, you have to see that when I rotate this circular part, how much movement I have on the main scale. Now this is basically a working of a screw gauge. You have threads on the screw, and when you give a one rotation, then there is a linear movement of the one of the thread. On the circular scale, the marking is from 0 to 50. In fact, 50 is again coming on 0. That means cycle is complete. So 50 is not written. On the lower side you can see 45. Then it again becomes 50. So this is a circular scale because it is repeating. So there is no need to write 50 on it. But we can notice that in the present screw gauge, I have 50 divisions. On the main scale, on circular scale. And when I make a rotation, for this what you can do is, you give 5 rotation, count them, say start from 0, rotate and again try to come to 0. This way repeat it 5 times. You will notice that the linear movement of this is going to be the 5 smallest divisions on the main scale. It means that one full rotation is giving the movement of one smallest division, which means that the 50 divisions is equivalent to 0.5 mm linear movement. Now if I have to calculate the least count of the screw gauge, for this what I mean is that when I move from one unit scale movement on the circular scale, the one single division is going to give me 0.5 mm divided by 50, which is equals to 0.01 mm. You can just notice that if you just calculate, you will get this 0.01 mm. It means that the screw gauge is capable of measuring the 1/100th of a millimeter. Just compare it with the vernier caliper. There we have 1/10th of the millimeter, and in this case we have 1/100th of a millimeter. I am repeating it again. Try to understand that how we can do it. On the main scale, first of all you have to find out that what is the least count of the main scale. For this we can notice the least count is 0.5 mm. Then by giving the 5 circular rotation and looking at the movement, we can notice that one complete rotation on the circular scale will make it to move linearly the one smallest division on the main scale. That means the 50 divisions of the circular scale is equivalent to the movement of 0.5 mm. Now to calculate how much one division on the circular scale means, what I did, I divided it by 50 and we got this as 0.01 mm. And this is the least count of screw gauge. It is very important. For all measurement, we are going to make use of this particular unit, that is the least count of the instrument. The next step is to find out the zero error of the instrument. The name itself tells you that what is the meaning of the zero error. When you make the movement of this using the ratchet in order to close it, that means the anvil and the spindle, this is anvil and this is spindle, they are now in contact. When you try to bring them in contact, you are required to use this ratchet, the last screw here. Don't try to close it by using this portion. If you use this portion, then it can forcefully will make the movement, and that may deform your spindle or going to get your instrument damaged. So please don't try to use this portion. When you have a large gap, you may use it, but when the gap is very small, then try to use this ratchet and you get a sound. This type of a sound is there. That means this ratchet is telling you that two are in contact and they have a sufficient pressure. There is no need to go further close to it, right? So when you have this thing done, then you will get three situations. One, you can notice that either we have the zero on the main scale is exactly coinciding with the circular scale zero. There is in fact a line on the main scale, and that gives you an indication that this is the baseline from where all measurements are to be made. So when you have this zero matching with this main line, then we say that there is no zero error. No zero error. Although we record it and saying the zero error is 0.00 millimeter. But there are other two situations are like this. You can notice that the zero of the circular scale is lying below the central line on the main scale. This means the error is positive. How we can calculate it? Try to calculate how many division it is lower. In this present diagram, we can see it is 1, 2 and 3. There are 3 divisions which gap between the zero of the circular scale and the central main line. Then you multiply it with the least count, and the least count we have worked out, that is equals to 0.01 millimeter. So this is error is positive and is equals to 0.03 millimeter. This number can be different, right? When you do the experiment in the lab, you may find this number maybe 2, maybe 7, maybe 8, and accordingly you have to multiply it with the least count. Now there is another possibility that you may have the zero going upper than the central line. Then, for example, in this particular case, this is a situation where it has gone up by 2 divisions. Or if you just calculate, this is 45, 46, 47 and 48. So please notice this way, if it is say 48, you subtract it from 50 and that makes it 2. Or directly you can count that how many division it has gone up. If it has gone up, say for example 2 divisions, it means your error in this case is negative and is 2 multiplied by the least count, which is 0.01 mm, and that is minus 0.02 mm. So let's quickly revise it. When you have the zero of the circular scale coinciding exactly with the central line, there is no zero error. But if the zero lies below the central line, then count how many divisions it is below the central line, take that number, multiply it with the least count, and that is the error, and we call it as positive error. Similarly, if 0 goes upper than the central line, then again count how many division it has gone up, and that division number multiplied by the least count will give you the error, but this error is a negative error. And please remember this, if you are going to get a positive error, in your final observation you have to subtract it, and when you have a negative error, you have to add this error when you go for the final measurement. Now students, we are ready for doing the measurement, and today's task is to find out the diameter of this wire using a screw gauge. Now the first step is to find out the least count, and least count measurement already we have explained, and the least count we calculated was 0.01 mm for this screw gauge. The next step is to find out what is the zero error of this instrument. Now to find out the zero error, we have to make the movement of the spindle using the ratchet till I get the sound. This is the sound which I am expecting. Now once it is done, the very first thing we have to note down is that zero of the circular scale, is it lying below the center line or above the center line? And I can notice that the zero lies above the central line. And if it is lying above, this means my error is negative. Very first thing. Then how many such small steps in circular scale it is above? If I count, I notice that these are the 7 steps, right? You can notice that 45 is written over there and 2 more steps there. 0 to 45, 5 steps, 2 more, 7. That means 7 multiplied by 0.01, and that is equals to negative 0 minus 0.07 mm. This is the zero error of the instrument. Now the next step is to find out the diameter. To find out the diameter, we are doing it in 2 orientation. One, where I take the horizontal diameter, right? I am keeping my wire like this. And next step, what I am doing is, I am just rotating it by 90 degree and keeping it vertical. This will ensure that if there is any dissimilarity in the cross section which has to be perfectly circular may not be there. So if there is small error, we can notice it, and doing the average will give me more accurate value towards the actual diameter of this wire. So let's do the first observation. So you just open up first of all the gap between the two slightly more than the thickness of the wire. Then choose the smooth part of it and put your wire in this way. Alright? And once you put it there, wire, you just try to close it again using the ratchet and wait for this sound. Once this sound appears, that means my wire is sufficiently fixed in these two gaps, right? And let's notice that what are the observation on the main scale and the circular scale as per the table given here on the board. And I can notice that in this case I am clearly getting the first division visible to me, and the first division, as we have seen, is equivalent to 0.5 mm. This already we have noticed when we calculated the least count of the instrument. So the circular scale, the value is 40. This is 43. The circular scale value is 43, and when I multiply it with the least count, that means I am doing 43 multiplied by the least count, and that gives me 0.43. So this is the main scale observation and this is the circular scale observation. Although there is no need to write this mm here because already we have kept it on the top of this table, so it means that all observations taken are in millimeter. Then for final observation we have to add the two, and if I add the two, that means 0.5 plus 0.43, and that gives me 0.93 mm. This is the observation which I am getting from my first observation. Now similarly you go for two more observation. For this you lose it a bit, take out the wire and put it again in the same geometry and try to close it again. And once this sound comes, that means now your second observation is ready. But for this I am keeping the same orientation as I kept for my first observation. Similarly you record third observation, and then you orient this wire at 90 degree now and again record the similar observations. So 3 in one orientation, 3 in other orientation which is perpendicular to the first one is going to give you the sufficient observation for finding out the diameter of the wire. Or you can do one thing, you can repeat all these at the other portion of the wire, because it may be possible the wire is not having a uniform cross section, right? So students, after taking these observations, I got these results. In my first orientation, there is a change in the circular scale division. Initially it was 43, then 41, 45, and the next orientation that is perpendicular to it, I got 42, 43, 44. Now by doing the measurement, I got these results. Now what I have to do is, I have to take the average value, and if I add all of them, now this comes out to be 5.58 divided by 6, and that is equals to 0.93 in millimeter. But this is the observation which I observed. It is not the correct observation. So what I should do, I should write that the observed value is 0.93 mm. But it has to be corrected. As there was a zero error in it, so we have to correct it. So corrected value is 0.93 plus. Please remember, since my error was negative, so I have to add this error, and this was 0.07, and if I calculate, this comes out to be 1.00 mm. So this is the diameter of the wire as we have calculated from the screw gauge.